Day 55 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. If this is your first time on the channel, welcome, welcome. If this is your second, third, fourth, or 55th time on the channel, welcome back, guys. It's good to see you again. Today we have a good problem. I hope this page is helping you guys to stay motivated and disciplined to keep learning, and I hope you guys are learning, actually learning as well, because that's what it's all about. We're all here to learn something, and we're all here to help each other up if we get stuck or anything like that, because we all understand when you're learning how to code, especially if you're self-taught or teaching yourself how to code, it could get difficult when you get stuck and you have nobody to ask. So that's why this page is one of the reasons why this page is created, so we could build this community and build this network of Swift programmers. So if we get stuck or we need help with something or we just want to learn something for the day, we could come to this channel and we could solve all our problems or as many problems as we can. Now with that being said, guys, don't forget, bring a mouse right over here, guys, right over here, and click that subscribe button. Then after you click that subscribe button, go ahead and smash that like button for me, guys. And then after you do that, you already know I need you to go into the comments and drop that bank emoji in the comments. All of my bankers out there, go ahead, drop a bank emoji in the comments so we can run this engagement up and we can build this community up, and at the same time build our knowledge and bring more awareness to Swift and the Swift programming language in general. Now, with all that being said, guys, let's see what question we have here today. Today we have question number 1161, maximum level of a binary tree. The difficulty level is medium, guys, but don't be scared. Even if you're a beginner, we're going to keep the solution as simple and easy to understand as possible, so don't let that deter you. And yeah, so let's see what the question says. It says, given the root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes at level x is maximal. So let's look at example 1 to see what they're talking about. We have an input, we have a root, a list of nodes. The output is 2. So the explanation is level 1 sum equals 1, level 2 sum equals 7 plus 0, which is 7. Level 3 sum equals 7 plus -8, which would be -1. So we return the level with the maximum sum, which is level 2. Okay, so let's break that down. We look at level 1. This is level 1, this is level 2, and this is level 3. So there's 3 levels in this tree right here. Level 1 has a value of, or a maximum sum of 1, because there's just one node and 1 is just 1. Then we have level 2, the value or the maximum sum of level 2 is 7, because 7 plus 0 equals 7. Then we come down here to level 3, the maximum sum is -1, because 7 plus -8 equals -1. But remember, we want the maximum, the highest sum, right? So that would be level 2, because that equals 7, and it would be 1, 7, and -1 would be all of the sums, and 7 would be the largest integer out of those 3 sums, and that comes from level 2, which is why we're returning 2, because level 2 has the maximum sums. Level 2 sum is the maximum out of all of them. So let's look at example 2. We have the root, the list of nodes. The output is 2, and that's the same reason. If you draw this, I've explained how these lists of nodes work in previous videos. Actually, day 54 and day 53, I believe. Definitely day 54. The video I did yesterday explains how these lists works as they correlate to the picture of the tree. So if you don't understand that, I would suggest you go look at video 54 or video 53, so you can see how how this list of nodes correlates to the tree. However, if we were to draw this tree using this list of nodes, level 2 would be the output, because would have the maximum sum, obviously, because the maximum because the output is 2. So yeah, that's the logic behind how this works and how the question wants us to figure out, or how we get the output that we want from this question. So let's go ahead and start with the code, guys. It's not that difficult to understand, as you know. So let's follow along, and I'll see you at the end of the solution. So the first thing we're going to do is we are going to say guard let root equal root, else we're just going to return -1. Then we're going to come down here, we're going to declare a variable called q, which is going to be it's going to be an array of roots, excuse me. Then we're going to come down here and say, guys, we're going to come down here, we're going to say declare another variable called cur level, and this is going to represent the level that we're on, and we're going to just set that to 1. Then we're going to come down here and say var result, and this is going to be equal to int dot min comma 1. And what this is going to do is it's going to store the maximum sum with the corresponding level. So then we're going to come down here and we are going to say while exclamation point q dot is empty, which means while q is not empty, we are going to say declare another variable called count. We're going to set that equal to q dot count. And what that is going to do is it's going to keep the number of nodes at the current level that we're on. Then we're going to come down here and we're going to say declare another variable called temp result, and we are going to set that equal to 0, and that is going to calculate the sum of the current level. So this is going to get the nodes of, so let's break it down. This is going to get the nodes of the current level, and this right here is going to help us say when we calculate all of the sums of that current level, we're going to store that right here in temp result. Then we're going to come down here and we're going to say declare another variable called temp q, and that's going to be equal to an array of tree nodes. And what that is going to do is it's going to hold the queue, or it's going to hold a temporary queue for all of the nodes on the next level. So keep that in mind, guys, as we write this code. So now we're going to say for I in 0 up to count. Then we're going to say let node equal q I. Then we're going to come down here and we're going to say temp result plus equals node dot val. And what that's going to do is it's going to accumulate the node's values to the temporary sum. So then we're going to come down here and we are going to say if let left equals node dot left, then we are going to say temp, we're going to say temp q dot append left. Then we're going to come down here, guys, and you already know we have to do the same thing for the right. And to do that, we are going to say if let right, guys, equals node dot right, then we are going to say temp q dot append right. And what this is going to do is going to check all the nodes on the next level, and it's going to store them in temp q. So for when we get to the next level, we'll already have those nodes right there ready to go. So then we're going to come down here and we're going to say if temp result is greater than, is greater than result dot zero. Then we are going to say result equals temp result, comma, current level. So that's going to give us the sum with the current level of that sum. Then we're going to come down here and we are going to say current, it's current level. How do we write that? How do we initialize that? So current level, guys. We're going to say current level plus equals 1. And we're going to come down one more time and we are going to say Q equals temp Q. Then we're going to come down here and we are going to say return result 1. So let's run this, guys, and see what happens. Fingers crossed, fingers crossed. Ooh, okay, we have a typo. It says, where does it say? Oops, okay, so yeah, guys, you have to have equal white space on both sides of the equal sign. Okay, and then down here we have to, where's that? Line 43. This should be current level, not current level. Sorry, guys. So let's run it again and see what it says. And it's accepted. So let's submit it and see what happens when we submit it, guys. All right, that's what I'm talking about. And it's accepted. 283 milliseconds beats 81.48% of users with Swift, guys. Now that's what I'm talking about. So that's the solution. Go ahead, get this solution one more time. If you don't have it, get one more look at it. And that's the solution, guys. And until tomorrow, I'll see you guys then for another day, another LeetCode problem.